Electrical energy. The term energy is probably one you've often used. However, if you attempt to define it, you may find it difficult. Energy is the ability to make something happen. You have identified a number of things that happen in circuits. Charges move, compasses deflect, bulbs heat and give off light. What is the source of the energy that makes these things happen? In most of the circuits we have observed, the source of the energy has been the battery. Right, so the source of energy is the battery. In some circuits, there was no battery present. When a capacitor discharges, it can make these same things happen. So it must have been a source of energy, at least temporarily. In some circuits, the Genicon was used, but the source of energy was the energy stored in your muscles. Cranking action transformed the energy from muscle storage to the energy of moving charge and bulb releasing light. So the gist of these first couple paragraphs is that the sources of energy in our circuits are the batteries, the capacitor, and when using the Genicon, human energy. You know that batteries eventually wear down and may become dead. This means they no longer have sufficient energy stored in them to make something happen in the circuit. Some batteries are called rechargeable and can be reused. This is an incorrect term, however, since the battery's task was never to supply charge. The battery's task was never to supply charge to the circuit. It was already there, meaning charge was already there. These batteries would more properly be called re-energizable. So it's important to realize that the batteries aren't there to supply the charge, meaning the charge is already there, meaning where in the circuit. The charge is sitting in the circuit. It's in every conductor, like water in the pipes of your house, and it's just ready to move as soon as we make a closed loop. The circuit charge originates in every conductor and constantly recycles around the circuit. However, energy leaves the energy source and travels one way, leaving the circuit as heat, thermal, and light energy radiating from the bulbs, which are the receivers of the energy. The energy source might be the stored chemical energy in the battery or the stored energy in muscles used to crank a Genicon, the stored electrical energy in a charged capacitor as well. So the big idea here, emphasizing charge originates in every conductor in the circuit. It's in the wires. It's in batteries. It's just sitting there already. The energy, now, that's not everywhere. That is stored in the chemicals of the battery, the muscles of a person turning a Genicon, or in a charged capacitor due to conditions in the capacitor. Fresh batteries, such as a single D cell, generally contains two substances which we'll refer to as A and B. These are high energy substances, like some foods are known to be excellent sources of energy, which means that energy is stored in the chemical bonds within these substances. These two chemicals react inside the battery cell and release the energy that pushes charge around the circuit. The reaction is rolling down the energy hill when energy is released from the cell, and the equation for the reaction is right here. Substances A and B change into substances C and D, and they give off energy. In the diagram here, we start with substances A and B in the battery. They will turn into substances C and D, and in the process, energy is released. That's referred to as going down the energy hill. Eventually, however, substances A and B will be used up completely, converted into low-energy substances C and D. When only substances C and D are left, we refer to the battery as dead. Some batteries, however, are designed so that the chemical reaction is reversible. By pumping energy back into the system from another source, the chemical reaction can be forced in the opposite direction. The diagram on the right below demonstrates energy being absorbed into the battery, climbing the energy hill. And the equation for this is shown right here. This is when you plug rechargeable batteries into the wall, electrical energy from the wall combines with the low energy substances C and D and recreate substances A and B. So substances C and D become substances A and B. Energy is absorbed from your electrical outlet. The battery is now refreshed or re-energized. It can be used again to pump charge around the circuit. Parenthetically here, the term rechargeable is misleading since the battery never runs out of charge, right? Charge is in the circuit. It's in the battery already, sitting there like water in the pipes. Charge is present everywhere in the circuit and is not supplied by the battery. Repeat, is not supplied by the battery. Charge is not supplied by the battery. The battery simply supplies the energy needed to make the charge move in the circuit. The term re-energizable battery would be more accurate. So the bottom line here is re-energize is a better term than recharge when thinking about what's really happening, because energy is being put back into the battery, not charge.